for the first time this year, my favorite student. I did that Wednesday for the first time with my Phys 11s. It was the first time they'd seen that dumb joke, and most of them just didn't get it. And then as I continued going through the quiz, every 2 or 3 minutes, you would hear somebody else. They finally got the dumb joke. It was just kind of it took a while to spread its way through the class. Answer key. Okay. I see directions. I'm going to put a compass rose. Come on in. Glad you made it. We're marking the take-home quiz. Total distance is easy. That's going to be 11 plus 18, which is it 29 kilometers? Okay, 1 mark. Also notice I barely gave you any room. That's usually my way of hinting at you. You probably don't need to show much work, right? Gave you a lot more room for B, probably means you're going to dulp. Total displacement. So I'm going to go 11 north plus 18 east. 18's bigger than 11, so I drew the 18 a bit longer. The resultant is going to be from the tail of the first to the tip of the second. I can already tell you, because theta is going to go right here, north of south, east of west, what of what? Sorry? I can put in the east of north. All right, let's find the magnitude. D squared is going to be 11 squared plus 18 squared, because that's the hypotenuse. Remember, it won't always be the hypotenuse. We did one last lesson, that really complicated one, where we ended up finding the vertical line and had to subtract to get there. (11 squared plus 18 squared equals square root). Did you get 21.1 as a magnitude? 21.1 kilometers at opposite, adjacent. It's going to be tan theta equals 18 over 11. Typo, Mr. Dewick. By the way, just looking at this, I'm pretty sure theta is going to be bigger than 45 degrees. If this was 11 and 11, it would be exactly 45 degrees. So a bit of a built-in error check. So when I was typing and I didn't type the 18 when the 1 didn't kick, if I had done that and got 36, I would have right away said, I must have made a typo. I've done something wonky. It's going to be bigger than that. Shift tan of 18 divided by 11, 58.6 degrees. I would take 59 degrees. If you said 58.5, I would take a half mark off and say learn to round off properly, because it's definitely 58.6. So 58.6 degrees east of north. Or I would also take 31.4 degrees north of east. And that's what you would get if you went 18 over first and then 11 up. Yes? Where did I make a mistake?
21.9.
Is it 21 You're right, 21.1. Noah, welcome back after I made fun of you. You get a candy. Well played. Thank you. The way I would mark this, by the way, Noah, 1 mark for the magnitude, half mark for the theta, and a half mark for the what of what? North of south, east of west, what of what? Okay. Ooh, river question. I'm going to dulp. The river flows due north. I want to be able to do a nice big picture, so I'm going to draw the river way over here, I think. Boat is heading due east. I've scrolled down, so I've lost my compass rose, so I'll do a new one. So the boat is heading east. River is flowing north. I want the resultant velocity. Okay. This is a little bit different. The one we did, I gave you the resultant and we worked our way backwards and figured out the components. Here, actually, I kind of think it's a little easier. They gave me the components. How would I find the resultant? What would I do with these two vectors? How would I add them together, Wes? Tip to tail, you say. Well, that's convenient. So you're saying, yes, the tongue helps. This is the resultant velocity of the boat. And I think I told you in Physics 11, but definitely in Physics 12, as far as I'm concerned, if I show you how to do a question in the lesson going forwards, giving you the resultant and having you find the components, as far as I'm concerned, I can flip the question without having to have told you how to solve it, giving you the components, saying find the resultant, okay? Magnitude's gonna be 8 squared plus 16 squared equals square root of 320. You get 17.9? Did I get 17.9? I'm correct this time? Thank you. That's going to be meters per second at, I'm going to put theta right there. Theta always goes where the vector, where the resultant is coming from. Color, 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 color. You know what? I think it's going to be tangent again. Tan theta equals 8 over 16. 26.6. I would also take 27. Let's go like this. At 26.6 degrees. North of south, east of west, what of what? How do you get that? The of is always the nice line, so it's going to be of east, and then north. And now you're starting to see why I'll often draw the little archy arrow. That helps me figure out what direction I went from my of nice line. So this is going to be north of east. Did anybody do the other one? 90 minus that? Okay. That would be east of north, whatever 90 minus 26.6 is. 73.4, I think. No, 63.4. Okay. Oh, same as before. 1 mark for the magnitude, half mark for the theta, and a half mark for the what of what. If the river is 255 meters wide, 155 meters wide, how long does it take to reach the other side? So we agreed that for the airplane in a crosswind and for the boat going across the river, A is going to be 0. Just, it's overkill if I stick an acceleration. I could, but it's just, ugh. So we said that means we can start out with D equals VT. It's technically D equals VIT plus a half AT squared, but since A is 0, the half AT squared vanishes. And since A is 0, VI is VF, is V middle, is V, just V. We want to get the T by itself. But now, direction matters. This distance right here, is it a horizontal or a vertical distance? Horizontal. I might even be tempted to put a little dx there just as a gentle reminder, which means this is going to be dx and that's going to be vx. I'm not going to use the slanty. I'm not going to use the 17.9. It's going to be 155 divided by what? 16. .6875, how about 9.69 seconds? Not very long. 16 meters per second is pretty fast for a boat. How far downstream, Mr. Dewick? If north is up, isn't that upstream? Upstream is usually considered in river vernacular against the current. Downstream is usually considered with the current, so we call it downstream. Anyways, I think they want us to find that distance there. I think that is a vertical distance, a north-south distance. So I think I'm going to go dy equals Vy times t, where Vy is 8, t, William, I'm going to write 9.69, but what button am I going to hit on my calculator? Answer button? Yeah. 8 times answer button. Did you all get 77.5? Cool. Meters. So those ones were each 1 mark. Now we get to a more, oh no, sorry, I still got more. Never mind. Forgot, there's another half page here. Find the horizontal and vertical, okay, I've scrolled down, I see a compass direction, so I'm gonna draw a compass rose. A force of 140 newtons pushes 67 degrees west of north. West of what? West of what? West of what? I'm gonna draw a dotted line going north first. By the way, I'm imagining things. I started to draw the dotted line right here, but then I said, which direction do I want to go? I'm going to run out of room if I go left. So that's why you saw me suddenly move my pen over. I'm going to do the dotted line right here. There's north. What of north? West. How many degrees? So more than 45. So I'm going to say probably about like that. Did I do a small postage stamp size diagram, Connor? No, I drew a big diagram. 140, 67 degrees, and I guess these are going to be the components. This is going to be, oh, it's newtons, so what are we actually talking about here if the units are newtons? I'll call it Fy and Fx. And this is really a bad diagram. I should have extended this line to there, or what, but you get the point. It's a triangle. Is that okay? Hypotenuse, adjacent, opposite. So sine of 67 is going to be Fx over 140. Fx is going to be 140 times the sine of 67. 129. And Fy, well, if Fx is sine, which trig function do you think Fy is going to be? Of course it is. $54.7? How many marks is this question worth? How many things did we find? 1 mark each. Common sloppy mistake, and I even do it once in a while. Kids are in such a rush, they mix up the x and the y. So they'll say, oh, Fx is 54.7 and Fy is 129. I would only take a half mark off on this question, but if this was a multi-part question and you were using these values to find other stuff, that would domino through. So just be really meticulous and really cautious, Karn, my friend. I had a few of you ask me about this. I guess here, number 4, we're looking at it from the side. We have the ground. The rope makes an angle of 72 degrees, which would be pretty steep. And it's being pulled with 117 newtons. Find the horizontal and vertical components. I see it. It's going to be this. That's going to be the horizontal. That's going to be the vertical. That's a terrible Y. Hypotenuse, adjacent, opposite. Have you started to notice a little bit of a pattern with components? One's almost always sine, and what's the other one almost always? Cos. And that will be because if I'm giving you a component, that is the hypotenuse. So you'll never use tangent for a component. It's always going to be sine and cosine. So be careful with your first one, and the second one becomes obvious. Oh, heck, let's find the vertical. O and H, which trig function? Sine. It's going to be sine 72 equals Fy over 117. 117 times the sine of 72. 111.3. Cleo, if fy was sine, which trig function do you think fx is going to be? Of course it is. Which, that's kind of nice and symmetrical too. I kind of like that. 36.2. How many marks? 2? 1 each. This one, number 5, the wording confused some of you when I said find the east, west, north, south. What I really mean is find the horizontal and vertical components, but it's not horizontal and vertical. To me, vertical is up, north is that way. So I called it north, south, east, west. We'll call them X and Y in our picture, but the one that matches the Y, we'll call that either north or south, depending on which way we end up. And the one that matches the X's, we'll call it east or west, depending on which way it points. Says 65 degree, oh, compass rose, Mr. Duick. South of what? East. South of what? East. South of what? East. Start out going east first. South of east, 65 degrees. That's what we're talking about. The components would be 1 to the east and 1 to the south. It's kilometers, so it's distance. I'll call this one dx and this one dy. Color, 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 color. Opposite, adjacent, hypotenuse. dy, sine or cosine? As soon as I see the opposite for component, it's going to be sine. In my homework, then, I might be tempted to just go like this. dy is going to be 25.6 sine 65. I could go straight to that line if I wanted to. Although I think you're all good enough at formula manipulation that if you write sine 65 equals dy over 25.6, how would I get the dy by itself times the 25.6 over? What I am saying is you don't need to write 2 lines of work in your homework if you don't want to. Did you get dy is 23.2? Oh, of course it is. Yes? $10.8. 1 mark, 1 mark. And now, here's a question with some teeth. If you haven't noticed already, on your formula sheet, I've given you an equation for a vector equation for a boat crossing a river and for an airplane in a crosswind. They're on there. I think it says something like this. V eng plus V wind equals V ground. I abbreviated, but I think I actually wrote them out on your formula sheet. Now these are vectors. Also, I saw directions, so I drew a compass rose. McKenna, what's this question asking me to find? Oh! This! Well, how would I get that by itself? How will I move the V wind over? Am I going to end up subtracting vectors? Oh, cool. So you're telling me that the engine velocity can be calculated by taking the ground velocity and subtracting the wind velocity. So how do I subtract vectors, McKenna? I don't. What do I do instead? Do you remember? So I wrote this like this on purpose so that I could go plus, negative, and just kind of see it there. There's my vector equation. Now I'm going to do the DOLP part. V ground, west 250. Plus, V wind was originally north 45. What's the opposite of north 45? So my vector triangle is going to look like this. And my resultant is going to be like that. Now, if you didn't catch the subtraction, if you just said, oh, add them together, you'll get the same magnitude as everybody else, but your direction will be wrong. Okay? Theta is going to go up here. Color, 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 color. This is going to be the engine speed. The engine speed is going to be, it's still the hypotenuse, so it's going to be 45 squared plus 250 squared and then square root. Let's work out evenly. No. Will it? No. Almost. 254? Meters per second. At opposite adjacent. Hey, good old tan. Shift tan of 45 divided by 250. How about shift tan, Mr. Dewick, of 45 divided by 250? By the way, clearly the angle was not 0.003 degrees. I could look at that. No, I've done something wonky, and then I checked. Oh, didn't hit the shift button. Does that ever happen? Yeah. Did you get 10.2 degrees? North of south, east of west, what of what? So this is going to be south of east. If you got that, you would get 7 out of 7. Otherwise, how would I give out part marks? I would give you 1 mark if I saw that you had written that down on a test, because you've recognized, yes? South of west, Mr. Dewick. I thought I heard somebody say south of east. Let's try that again. South of west, nice call. Candy for you as well. If you got that, let's try that again. So here's how I would give up part marks. I would give you 1 mark if I saw that. Somewhere if I saw that you would recognize we were subtracting to get it by itself. Now, if you didn't show me these steps and you got it right, you're okay. But my point is, if you're in the habit of not showing all your steps and trying to do as much as you can in your head and not writing stuff down, then you might find that you're not getting part marks that you would like to get if you make a dumb mistake. Not that I'm mentioning anyone by name. Okay. Test or quiz, show your work. Okay. I would actually give you 1 mark for the vector triangle. I would give you 1 mark if somewhere I saw that you had indicated, I'm using Pythagoras. What's this question worth? 7? That's 4. 5. 6. 7. Okay. What that really means is, on these tests, although the questions, the written questions especially, are going to be tougher, it's really tough to get a 0. As long as you at least kind of know where we're going and you write some stuff down. Other bits of advice, because you're going to have some questions on tests where you're like, I got partway through and I think I made a mistake. Don't erase stuff or cross stuff out until you're sure. I will always put on your tests this year 1 written question per page. You'll have an entire page for a written question, and I do that on purpose so that you can make a mistake, try resolving it down beneath, see which one of these you like, cross out the one you don't want me to mark, and keep the one that you do, but you don't have to waste time erasing or anything like that. If you can give yourself a lovely score out of 20, and if you need to lawyer with me, now is the time. So going over the homework from last day, number 17, put a compass rose. River flows north, so I'm going to draw my river, how about right here. The boat's motor is putting out a velocity, so I guess the boat is going this way at 5.1 meters per second, and the river is 3.6 meters per second. This is really similar to the question we did on the quiz, actually, I think. So the resultant velocity would be the combination of those two. How would I add them together? Any suggestions? Tip to tail, you don't say. Okay, so whatever 5.1 plus 3.6, or you go 3.6 plus 5.1. I usually do the horizontal and then the vertical if I have a choice. And that's going to be your resultant, whatever that is. You're okay on the Pythagoras and the trig? Okay. B, if the river is 71 meters wide, hey, that's a dx. I think it's going to be time equals dx over vx. dx. How did I say x and write a y? That's a little weird. Yeah. So it's going to be 71 divided by, vx would be the 5.1. Yeah. And then determine the distance that the boat will travel downstream. In my picture, that's going to be a dy. So dy is going to be vy times time. And again, Noah, you were away, but why don't I need to put a subscript or letter on time? Why can I use time in both equations? It's a scalar, has no direction, so that I can use in any equation. In fact, you're going to learn later on Monday, you know what we're going to spend most of our time finding? Time, because it's the one thing that can be used both in a horizontal and in a vertical equation. That as soon as you get time, the question's going to fall apart when we're analyzing projectiles. If they give you the time in the question, that's going to make the question significantly easier. Is that okay, Carter? Yeah. Did you get this one on the quiz?
Yeah. I don't really.
That's okay. Yeah. You won't be the only one to get a directional mistake. That's by far the biggest challenge, is when we look at projectiles in particular, there's one very, very, very familiar number that you all know and love that you want to put into a horizontal equation, even though it's a vertical value. We'll talk about that when we get there. I'll have to lovingly beat that out of you. You're a nice, loving teacher. Any others from the homework? Going once? Okay. Try and use this weekend to get caught up. You might recall last year I told you I would try and avoid giving homework out over weekends. With the quarterly system, that's much tougher for me to plan for. I'll try and aim it so that you don't have homework on a long weekend. It will be my goal. We'll try and juggle things around, but you might have some homework occasionally. I mean, the good news is you're only doing 2 courses, so okay, but you're doing everything way faster. You may or may not want your formula sheet out. You might remember these because we flogged them quite a bit, but if you want to get your formula sheet out, you can. Lesson 5. Review of kinematics. What we spent most of before Christmas last year doing, and I think you joined us a bit late. I taught this to you between the cracks, so hopefully this will be a good review for you, Allie, my friend. First of all, acceleration. We defined acceleration as a change in velocity over a time interval. Huh? In math notation, what letter did we abbreviate acceleration with? What was our symbol for change in? It's a delta triangle over a change in time. Now, time was weird because time was always a change in. We get a bit sloppy and we drop the delta in front of the t. We just do. We could also write it like this. A equals, so instead of change in time, just over time. And what's change in anything? I could, instead of writing delta V, I could write VF minus VI. Josh, this can be rewritten if I get the VF by itself, if I times by T, if I plus the VI over. This is how we wrote it last year. VF equals VI plus AT. Y'all remember that? We used that quite a bit. It was a nice one. Again, just like last year, this assumes an unchanging or a constant acceleration. We will later on this year look at a changing acceleration. We will, but it's going to be changing its direction, not its magnitude. So we'll show you what we have to work around to handle that. Okay. If you have a changing acceleration right now, you need calculus or it gets ugly. If we have a constant acceleration, you can find the average speed, the average. The fancy symbol for average is a horizontal line. The problem is that looks too much like a vector symbol when I type it and shrink it down. So I think in your notes, I typically write the average. How do you find the average of two things? Sean, if you have $20 and if I have $30, what do we average between us? How'd you get a 25 from a 20 and a 30? Add them up and divide by. So if I want to find the average velocity, take VI, add it to VF, divide by 2. I'm going to stop putting the vector signs in. These are all vectors, but it's going to clutter up everything we write. So I'll bring the vector signs back in on our punchline at the very end. So since this is in a box, I will put the vector signs in, but when I rewrite it later on, I'll just temporarily chuck them because it makes things kind of hard to read. Displacement. Distance, or displacement, is average velocity times time. It's v times t. And since average velocity is VI plus VF, I can do that. And now we're going to do one more substitution. Since VF equals VI plus AT, since VF is the same thing as VI plus AT, since VF can be written as VI plus AT, I'm going to replace this VF with a VI plus AT. I get this. Big fraction line. What am I going to write instead of VF? VI plus AT. And then there's the second plus VI times T over 2. So Allie, this right there is that right there. And then the plus VI drop down like a domino. Because I replaced the VF with a VI plus AT. That's that. But also notice there was a plus VI right there. Okay. Oh, I should point out, you don't need to know how to derive this equation. I'm walking you through it because I'm a nerd, but I will not ask you to rederive this on a test. What's a better way to write 1 VI plus 1 VI? Is it VI squared or is it 2 VI? 2 VI. 1 VI plus 1 VI is 2 VIs. 1 car plus 1 car is what? 2 cars. Okay? So I can write this as 2 VIs plus an AT all over 2, and then there's a T outside the brackets. I'm going to move this T into the brackets. I'm going to times the T there and there. Did somebody say T squared? I thought I heard somebody murmur that. Look at that. We're going to get this. A D equals a 2, a VIT, and an AT squared all over 2. Starting to see where we're going? Okay. Josh, is this whole thing over 2?
Say yes.
So is this over 2? Say yeah. And is this over 2? I can split them up each over 2. I can write this as 2 VIT over 2 plus AT squared over 2. Sorry for those of you on YouTube sneezing into their headphones. Why did I do that? Look at that first fraction. Josh, is there a 2 on the top? Is there a 2 on the bottom? Really? They cancel. And we didn't write AT squared over 2. What did we typically write last year in this equation? And this gives us D equals VIT plus a half AT squared, where D is a vector, VI is a vector, and A is a vector. Ta-da! McKenna, really? You didn't see that coming? I even put it in bold font for you there. Oh man, you've forgotten what it's like in my class, people. It's been too long. And sorry for those of you on YouTube listening to this with headphones. Okay. There is one more equation. I didn't derive it with you last year. I'll derive it with you this year. This is going to be the squared one. So we start out again with saying distance is average speed times time. Same as we started out before to get D equals VIT plus a half AT squared. But this time, we're going to plug in average speed, VF plus VI over 2, because to find the average of anything, add them up and divide by 2. We're going to plug something in for T. T is VF minus VI over A. Don't write this down. How would I get the T by itself, Noah? How would I move the VI over? Yep. And then how would I move the A over? That's where that came from. Okay? So I can write this as D equals, big bracket, VF plus VI over 2, and another big bracket, VF minus VI over A. Karn, is this a fraction?
Yeah.
Is this a fraction? How do I multiply fractions? You don't need a common denominator. Multiplying fractions is the easiest. It's top times top, bottom times bottom. What's on the bottom of the first fraction? What's on the bottom of the second fraction? Carter, what's 2 times A? A squared? No. What's... So the bottom is going to be 2A. On the top, I have this, VF plus VI in brackets, VF minus VI in brackets. Hey, this is FOIL, or front door bomber if you had Mr. Rock. But this is, we can multiply this out. It's going to be everything in the front times everything in the back. We're going to get this. So there's going to be a D. On the bottom, there's a 2A. Look up and watch, don't write just yet. What's VF times VF? What's A times A? A what? So what's VF times VF? VF what? Write that down. Then, Josh, I'm going to have a positive VF times a negative VI. What's a positive times a negative? You're going to get negative VIVF. Remember that, remember that, remember that. Negative VIVF, negative VIVF. You're also going to get a positive VIVF. What? Like that. And then you're going to have positive VI times negative VI. What's a positive times a negative? What's VI times VI? And I forgot to put the A next to the 2 for some dumb reason. Sorry about that. I caught it. Can you see what we're trying to get here, Aiden? Times the 2a over. If you do that, oh, I've got more room here, good. You'll have a 2ad, and then you'll have a vf squared minus vi squared. Get the vf squared by itself. How will I move the minus vi squared over? Okay. So this is our final equation. Vf squared equals vi squared plus 2ad. The one I gave you last year, which I didn't blatantly put on your formula sheet, you can add it to your purple one if you really feel you need to, is this one. You can add it to your purple sheet if you really feel you need to, but what did I give you? I think I gave you this. Did I give you V average equals VI plus VF over on your formula sheet? Yes? And since distance equals V average times T, it kind of pops into there. It's up to you, but I don't want it on your yellow sheet. The other thing is we're almost never going to use this year. That one is kind of a redundant one. You can find something else and then you don't need it. Anyways, let's do some examples. Remember that DFIC method that I showed you last year, which was list your stuff out? We'll start with that until we get good. Dragster has an acceleration of 38 meters per second squared. It begins from rest. I would probably underline the word from rest. Ooh. Nick, what's A asking me to find? Okay, in terms of physics, what's it asking me to find? V what? Yes. What's that 38? How do you know? What if it hadn't said meters per second squared? I'd still figure it out, right? 38, roughly how many G's is that? Who remembers how big 1 G of acceleration was? About 9.8, roughly 10. This is just under 4 G's, probably right around 4 G's. Okay, that's a dragster. What's from rest? Tell me. What's that 2.1? And are all my units nice, or do I need to do any conversions? Then I didn't even bother writing the units out because I'm that lazy. I checked as I was going. If I'd seen kilometers or hours or micro something or whatever, I'd do some conversions. Which equation? Nick, my friend. Which equation? Yeah, I gave you the easy one. Because normally then I would say we want, oh, did you read VI? Don't waste my time. I think we could have just done that, yes? Why could we have just gone straight to AT? Yeah, 0. So it's going to be 38 times 2.1. Normally our next step would be get the VF by itself. Hey, it already is. 38 times 2.1. I can do that in my head. 38 times 38 is going to be 76 plus 3.8. 79.8. Double check me. Right around now, I usually remind you, an easy way to stay with the lesson is to always follow along on your calculator. So the fact that only about 3 of you type that into your calculator, next time all of you will be typing these into your calculator. It's good practice, you get faster, it keeps you engaged in the lesson. And also, I do make mistakes when I do the math in my head, especially if there's trig involved. Connor, what's B want me to find? Probably technically a displacement. In fact, really, because direction's going to matter more this year, I probably should have put the vector sign on the V and on the A just to remind myself, pay attention, pay attention. You're really going to notice it in the next lesson. Is it still the same amount of time as part A, Connor? Then I'm not going to relist my data. Which equation? That's not an equation on my sheet. Oh, Remember, it's actually d equals VIT plus half AT squared, but what's VI? 0, so don't waste my time. Sure. Oh, and the d's already by itself? Well, that's cool. So 0.5, 38, 2.1 squared. Do that one in your head, Mr. Dewick. I can't. I got to go to my calculator. You get 83.8. If I go to 3, typically this year we'll round to 3 sig figs unless the question says different, or unless I know I'm going to be using that to find something else, then I go to 5 or 6. Meters. Cool. Aiden, what's C want me to find? V final for C? How long will it take to reach the dragster to reach a velocity of 126 meters per second? I think I disagree. Because what is that 126, do you think? What are the units next to it? It's a velocity. What was VI? What was VI? 0. I think that's V final. So don't take this wrong, but I'm going to say that's probably a bad guess, V final. So again, how long? What's that asking me to find? That's a tricky one because how long can mean distance. How long is a football field? It can mean time. How long was the movie? And I phrased that one vague on purpose to remind you we always got to be careful with how long. Time. So T equals question mark. Is VI still 0? Yes. Is A still 38? Yeah. Is D going to be 83.8? No, because different V final. Oh, in fact, V final is 126. Aiden, which equation has a T, a VI, an A, and a VF in it? I know, it's been a while. We're brushing the cobwebs off. Get the T by itself, please. I agree with that. What's going to drop down like a domino? First, what side is the T on? Left side or right side? Well, in the original equation. So the left side drops down like a domino, the VF. And then, what's right next to the T? How will I move the A over? Remember that, remember that, remember that. What else is on the same side as the T? VI? How will I move the VI over? Now, VI is 0 this time. I'll put, just to jog our memory though, I'll put it in there. And then over, remember it was always reverse BEDMAS, right? So you did your adding, subtracting first, then you multiply, dividing. And yeah, VI is 0, so I technically didn't need to write it. Okay. What's VF? What's A? Which is what? This might work out to a nice decimal. No? Oh, sorry, I didn't make it work out nice. 3 point what? To 3 sig figs, please, as I think I said about 20 seconds ago. Okay. 3.3, rounded off properly. Cool. Coming back to us, remember all this? Hopefully pretty familiar because most of you did really good on this stuff. Cleo, what's D asking me to find? Yeah. So D equals question mark. I think VI is still 0. I think it's still accelerating at 38. What's that 153, Cleo? Yeah. Looking for an equation that has a D, a VI, a A, and a VF in it, Cleo. There is one. Yeah. All right, let's get the d by itself. So the d is on the right side. So the left side, the VF squared drops down like a domino. Then what? What's right next to the d in that equation? And also the number 2, right? Is it 2a? How would I move the 2a over? What's the 2a doing to the... Sorry? Remember that. What else is on the same side on that equation? It's also, I think, a vi squared. Yes? How would I move the vi squared over? Is the vi squared multiplying the d? Okay. So reverse bad maths, it's going to be minus vi squared and then all over 2a. You don't have to write the vi squared because it's 0, but in our notes, I'm just doing this to remind you how we were able to rearrange all of these. So it's going to be 153 squared minus 0 squared. I probably didn't need to write that. All over 2 times 38. Oh, is this a fraction? Yeah. Is there more than one thing on the top? Actually, without the 0 squared there, no. Is there more than one thing on the bottom? Brackets around the bottom, unless you have the fancy schmancy fraction button. What have I done wrong? Why did I get 441,771? I forgot to put the brackets. Hopefully you would notice that that's a pretty big distance. I hope. Did you get 308.01? 308 meters. Next page. When the dragster hits a top speed of 162 meters per second, I tried to make these numbers realistic. I looked up, can't remember which dragster I looked up. They had a web page, and I was pulling their data off and converting it. So its top speed was in kilometers per hour, but I converted it to meters per second. Pulls its chute. If it takes 12 seconds for the dragster to come to a stop, what's its average acceleration? Okay. Cool. Karn, what's A asking me to find? Why did I say average? I suspect in real life the acceleration isn't constant. I have been on the end of a parachute. Initially there's a big jerk and then it's not as big, but we can't handle a changing acceleration, but we can find the average acceleration. So really you could have said average acceleration. It's asking me to find A. Okay. What's that 162? Well, it's a meters per second. I agree. So it's a velocity. Which one? I disagree. What's V final? Read the question very carefully. What's V final? So if you didn't underline the phrase come to a stop, you want to remember that habit that we always look for words like that? Okay. What is V final as a number exactly? 0. Which means what must that 162 be? Not V final, but gotta be V initial. Ooh, Karn, are we speeding up or slowing down? Am I expecting a positive acceleration or a negative acceleration? Yeah, if I get a negative, I won't freak out. I'll relax. Okay, what's that 12? Time? Karn, I'm looking for an equation that has an A, a VF, a VI, and a T in it. There is one. Get the A by itself, please. Smooth as silk. So 0 minus 162 all over 12. Put the bracket in the wrong place, do it. Definitely need brackets around the top. Karn, did you get negative 13.5? So about a G and a half, a little less than a G and a half. Units or meters per second squared. Then Josh, what's B asking me to find? Other Josh. I'll try and make eye contact with you. Sorry? So, what's it asking me to find? This is also a how long question, but I don't think it's asking me this one to be time, because I think time is 12 seconds. So, yeah. I think it's still part of the same question, Josh, so I'm not going to relist VI, VF, and T. I think they're there. I'm looking for an equation that has a D, a VI, a VF, and a T in it. There is not one. There is the one from last year that I said you could add to your purple sheet if you wanted to. But we're in Physics 12 now, Josh. What else do we know? What did Karn just figure out in Part A? I'm going to use D equals VIT plus a half AT squared. I'm a big boy now. I'm going to use an answer that I previously calculated because I'm confident it's right. And it's less work. So it's going to end up being 162 times 12 plus 0.5 negative 13.5 12 squared. Josh, is the dragster moving forwards or backwards after we pull the parachute? Be obvious. When you pull the parachute, the dragster suddenly flips in reverse and starts traveling backwards? Yeah. So here's my question. I'm expecting a positive displacement or a negative displacement. Better get a positive one. And look up, folks, these are vectors, so I'll definitely put the negative in for the acceleration. Not a 13.5. That's why I put the negative there. What do you get? You get 972? Takes almost a kilometer to come to a stop. And meters. Example 3. I think I told you in Physics 11 that in Physics 12, we'll do a lot more questions purely algebraically without numbers. So here's an example of one. How much more do I need to get? Oh, okay, I only got one more and then we're done. Okay. I can see you're getting restless, Cleo's stretching, and I've been talking for a little over an hour. McKenna's trying to keep her eyes open. I got it. So let's finish this, and then you can take a break and work on some homework as well. Okay. An object starts at rest. How are you not underlining? Wow, people. I even paused. Accelerates east at a constant rate. I might draw a compass rose, but they gave me a picture. I think I'm just going to treat east as moving to the right, and I think I can handle this okay. When it's traveled 10 meters, it's moving at speed v. How fast will it be moving when it has traveled 20 meters? Select the best answer. V, more than 2v, exactly 2v, or less than 2v but more than v. Ah. So here's what this is saying. After 10 meters, it's traveling at speed, I don't know, v. How fast will it be moving when it's traveled 20 meters? The same speed? More than twice as fast? Exactly twice as fast? Or faster, but not twice as fast? Got the argument? We could vote, but let's see if we can turn this into a proof. Because it says explain your answer using appropriate principles of physics. Let's see if I can prove it. Any suggestions? By the way, you could do this purely algebraically, and it would make my little math nerd heart sing, and that's fine. But another strategy, go ahead, Carter. I don't know. I don't know. I want a proof. Here's the first, you're going to get a lot of these, what are called using principles of physics questions. There's going to be one on almost every test. Sorry. We're going to practice. We're going to get there. I'm going to try and give you a bunch of tools in your tool belt to answer these. And the first one is, when in doubt, try making up some reasonable numbers. So they already told me that VI was what? Then it says accelerates east at a constant rate. Let's make up a nice acceleration. What would be a nice number to work with for acceleration? Don't say 3.74. What would be a nice number? 5? I'll take 10. I take. The only one I would never use is 1, because when you multiply by 1, you get the same answer, and you might spot a pattern that actually isn't there. So never, when you're making up reasonable numbers, never use 1s or 0s. 5s are nice, 10s are nice. If I'm doing a really complicated calculation, one of my go-tos is 48, because so many numbers go evenly into 48. I'm hoping I'll get a nice answer that just works out evenly. But so let's say A is 5. What's that 10? Could I actually calculate what V final is in the first situation? Heck yeah. How would I calculate what V final is in this first situation? Which equation? What's VI? So I'm just going to write VF squared equals 2AD. Is that okay? How would I get the VI by itself? Sorry, the VF. How would I get the VF by itself? Because it's not quite. How do I get rid of squared? Okay. So in the first situation with our made-up numbers, how fast are we traveling after 10 meters? Stop. Stop, stop, look up, look up, look up. So you said, isn't it going to be the same? What number am I putting in for D right now in the first situation? In the second part, what number would I put in for D? Can it be the same? Cross out A. See it? Can't be the same, because I'd be plugging in a different number in the second situation. All right, let's keep going. What'd you get? Do you get 10 times 10? The 5 was a really nice pick, by the way, because I think you get the square root of 100, and you get a lovely V final of, yes? Now, let's repeat for situation number 2. Stop. Let's be organized. But lazy. Here's what I would probably do. I would go like this. Situation number 1, put a 1 there. And then by the 20, I would put situation number 2. I'll put a, you know what? Oops, I erased something I didn't want to erase. I'll do situation 2 right here. I've changed colors so you can see easier. You don't need to. I'd figure it out. Situation 2, we're going to do the same thing, except what's going to change? What's the D going to be? Do I need to rewrite everything? Which is what? More specific? 14.1, I think, if it's square root of 200. You do that in your head, Mr. Duke? Yeah. It's really the square root of 100 times the square root of 2. What's the square root of 100? 10. Square root of 2, I know, is 1.414, so I did a little math in my head. So, if you go twice as far, are you going twice as fast? What's the correct answer? B, C, or D? Oh, definitely not more than 2V, because that would have been bigger than 20. We didn't get that. Oh, definitely not exactly 2V. Yeah, D. Faster, but not twice as... And why is that the case? Because of that square root. If you want to be fussy, you're going root 2 as fast. If you travel twice as far, you're going that much faster. If you travel 3 times further, you're going that much faster. If you travel 8 times further, you're going that much faster. That would be a generalization. So D, where it says explain your answer using principles of physics, we did. Oh, I might say something like 14.1 is bigger than 10. What do 3 dots mean? Therefore, D. Okay. I would not give you one like this right now on a test today because you haven't practiced enough of these. And they'll get tougher as the year progresses, but for now, strategy number 1, make up some nice numbers and try and compare the situations. That'll work. Sometimes. As you get better, we will reach the point where we'll do some completely algebraic physics proofs and our little math nerds' hearts will go pitter-pat. What's your homework? 1 is good, 2 is good, 3 is good, 4 is good, 5 is good, 6 is good. I am going to skip some here. You can skip 7, you can skip 8, you can skip 9, or as I like to say, 9. That's so. Sorry for pounding my desk. Those of you on YouTube, that was probably loud on your headphones. 10 you can try. 10, you're going to be using relative speed and relative velocity. I haven't done a review of that. And I'm not going to be throwing relative speed or velocity on your test. But since we looked at that lovely airplane video, I couldn't resist doing at least one airplane with a tailwind and a headwind question. And now also, if you want to get a head start from the ultimate review, that big thing that I handed out yesterday, you're capable of doing those questions as well. I would encourage it. I got 20 after. I would encourage all of you, take a 10-minute break before you dive on in if you want to.